Hello everyone. Today we are going to begin chapter number 7, electricity and magnetism. This is the last chapter. Okay, so in this chapter we'll study about what is magnetism, what are the laws of magnetism, test for a magnet, what is electromagnetism, and what are the application of electromagnets. And at last we'll study about electric bell. Okay, so you might have seen when you keep a iron nail near a magnet. This is the iron nail, and you have kept this iron nail near a magnet. This is a magnet. Then this magnet will attract the iron nails. Okay, this magnet will attract the iron nails. Why? Because of the because of the magnetic property of this magnet. Okay, so what is magnetism? The property by a magnet to attract magnetic materials. Magnetic material means the objects made up of iron, nickel, cobalt and steel. Okay, the objects which are made up of iron, nickel, cobalt and steel, these are called magnetic materials. Okay, so when the magnet attract this kind of materials, the magnetic materials, that is because of the property. Okay, the property of the magnets, that property is known as magnetism. Okay, so when you keep a iron nail near a magnet, it will attract the iron nail. Okay, but when you keep a plain paper or a wood, okay, then the magnet do not attract such kind of materials. Why? Because magnet attract the magnetic materials, okay, and the magnet also. Okay, so the materials which are attracted by the magnets, like the iron, steel, nickel and cobalt, okay, the magnets which are attracted by the magnets are called magnetic materials. Okay, and the materials which are not attracted by the magnets, like the paper, woods, gold, silver, stainless steel, these kind of materials are known as non-magnetic materials. Non-magnetic material means they the metals which are not attracted by the magnets. Okay, then laws of magnetism. Okay, so we know that in a magnet, the magnet has two poles, north pole and south pole. Okay, and if you keep a magnet near another magnet, okay, if you keep the north pole of one magnet near the north pole of another magnet, this is magnet A and this is magnet B. If you keep the north pole of magnet B near the north pole of magnet A, then they repel each other. Okay, but if you keep the north pole of magnet A near the south pole of magnet B, then they will attract each other. Okay, and if you keep south pole of magnet A and near the south pole of magnet B, they repel each other. That means like poles of a magnet repel each other. If you keep north pole of a magnet near the north pole of another magnet, and if you keep the south pole of a magnet near the south pole of another magnet, they repel each other. That means like poles of a magnet repel each other, and unlike poles attract each other. That means if you keep north pole of a magnet near the south pole of magnet of another magnet, they will attract each other. Okay, Okay, now if you suspend a magnet, a piece of magnet, okay, then it always rests in north south direction. If this is a magnet and if we suspend from a rigid support, then this magnet always be in north south direction. It never be in east or east and west direction. Okay, it always be in north and south direction. That property is known as directive property of magnets. Okay, clear? Okay, now if you suspend a magnet, a piece of magnet like this, the one end which are towards the north pole of the geographical north pole, okay, the one end which are towards the geographical north pole, not towards the geographical north pole, that is known as north pole of the magnet. Okay, like that, the one end which are towards the south pole, geographical south pole, that is that end of the magnet is known as south pole of the magnet. Clear? Okay, okay, then the poles of a magnet cannot exist independently. That means we can never have a magnet that has only north pole or only south pole. They always occur together. Okay, if you break down the magnet, okay, if you break down the magnet, the it has north pole and south pole always. Okay, they always occur together. Clear? Next, test for a magnet. So repulsion is the sheerest test of magnetism. Okay, but why repulsion? Why not attraction? Okay, because magnet attract the other magnets. Okay, other magnets and other magnetic materials also. But why repulsion is the sheerest test of magnetism? Let's see. Let's say this is a materials. Okay, and we have keep this material near a magnet. Okay, now if this material do not attract by the magnets, if this material do not attract by this magnet, then it is a non-magnetic materials. Okay, but if this material attract by this magnet, if this material attracts by this magnet, then it can be a magnetic materials. It can be a magnetic materials, or it can be a magnet also. It can be a magnet also, because we know that the unlike poles of magnets attract each other. So if this material attracted by the magnet, it can be a magnetic materials, okay, or it can be a magnet also. Okay, so repulsion is the sheerest test of magnetism. If this material, okay, if this material and this magnet repel each other, then we can say it is a magnet. Okay, but if these materials are attracted by the magnet, then it can be a magnet or it can be a magnetic materials. That's why the repulsion is the sheerest test of magnetism. Clear? Then electromagnetism. Okay, so electromagnetism, so this is a battery, okay, and this is a switch. Okay, and this is the conducting wire. Okay, and this is a soft iron core. Okay, this is a soft iron core, and this wire, this insulated wire, is wound around the iron core. Okay, like a coil. Okay, this is the coil. Now when you switch on, the current start flowing through this wire. Okay, now when the current start flowing, this iron core behave like a magnet. Okay, this whole phenomena is known as electromagnetism. Clear? And this magnet is known as electromagnet. This magnet is known as electromagnet. Okay, so when an electric current is passed through a coil of insulated wire wound around a soft iron core, that core behaves like a magnet. This phenomena is called electromagnetism, and the magnet so form is called an electromagnet. Okay, then some applications of electromagnets. We use this electromagnets in electric motors, electric bells, and electronic switch. We use electromagnets for lifting heavy vehicles, loads of iron, and we use electromagnets in mining industry also to separate the iron ores. Okay, ores means this is a kind of rock. Okay, then we use electromagnets to deflect beams of electrons in televisions. Then electric bell. Okay,
Electric bells. Yes, most of the bells we see nowadays are electric bells. Here's a very simplistic diagram of an electric bell. This is the inner structure of the bell. Let me first tell you the names of the basic components. This is a push switch, which is nothing but the switch we press when we ring the bell. This is a coil of wire wound around an iron piece. There could be two coils of wire wound around an iron piece as well. Remember, we've just drawn a simplistic version of the actual circuit. So it will act as an electromagnet when the electric current flows through the circuit. This is a battery and this is a striker which strikes this gong. That's when we hear the sound. So we can see that this is a circuit that can be formed. It's not complete. Why is it not complete? Well, we haven't pressed the switch yet. When we push the button, this circuit gets completed and the current flows from the positive to the negative terminal. But when the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts this soft iron towards it. And in the process, the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. As soon as the soft iron is shifted away from its original spot, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we release the push button, the circuit breaks and the bell stops ringing. That's the basic idea of how an electric bell works.